Hi everybody, this is Tor Storley and I am back with another video. In this video series, we're going to be looking at how to perform some stock analysis using TidyQuant, Positron in R, and also we're going to be using DuckDB. So this is the first video in a series. So in order to get a hold of Positron, which is out on GitHub and also on the Posit website. So if you open up a browser here and you search for Positron, you're going to get here and you can see there's some stuff for Wikipedia, but that's not the one we're looking for. We want to get in here for the Positron. But this is the GitHub repository, and then you have this one down here. That's the one you want to go to here, this one. So what is this? Well, Positron is by Posit. And you can see there's a startup page here, and they tell you about this project they are using. And also notice what it says up here. Positron is available for beta testing and may not yet be a good fit for you. So you might still have to use RStudio. If you want to learn about the Positron software, make sure you check out this YouTube video because it will go through each stage of it so you can understand fully where it's coming from and how it can be used. And it's built on the same code base as VS Code, meaning it's gonna look very similar to that layout when you look at it, which we will do in a second here. But anyways, you can see it here, so make sure you check out this video if you want deeper information about it. And also, there is pages like you can get started with Positron on this page, which you can see is the positron.posit.co/start.html. So here you can go first, and then you can also download Positron from here, which is the positron.posit.co/download.html. Here you can figure out what system you are on, whether it's Mac, Windows, or Linux, and you'll find the download right here. And in addition to this, you're also going to need, obviously, R installed, and I think it's up to 4.4 something. I can't remember. You can also go to get started here. There's guides, as you can see. You can click on this guides, and then you end up here. And we'll tell you a little bit how you can get going on in Windows, in Mac, and so forth. So make sure you check out this documentation. Also, there's a GitHub page, as you can see here. So if you look at the GitHub page, it will look something like this. And here's the code base. So in case you're interested in the code behind, you can go in here and find that. You can also see there's a bunch of contributors here, 32 in total, it says. And if you click on the contributors, you can see how much they contributed. And if you scroll down, you can see there are several people that has been contributing. And one person you might recognize, well, there might be a few of them you recognize, but this guy you probably heard of. This is Wes McKinney, and he's the creator of the Pandas library. And he also, as you can see here, was the creator of Pandas and IBIS, and it was also a co-creator of Apache Arrow. In any event, you can see some of these people you might recognize, maybe Julia here. She's done a few presentations in data science. So make sure you check out the documentation, and you can download, like I said, from here. So check that out. Okay, I'm gonna just open Positron now. So I'm gonna open it, and I'm gonna bring the window over here to this other terminal. Okay, so as you can see, I have created a Quarto document here that I call SMP500_R_DuckDB_TidyQuant.qmd. Now, we don't need this particular one, so let's get rid of that. Let's just save it. All right, so notice out here on the left-hand side that this should look very familiar to you if you use VS Code. You can see it's the same symbols and everything. And as you can see, I'm using a dark theme. And if you're familiar with VS Code in Windows, you can do a Control, or I don't know if Mac uses Command, but it's Control-Shift-P, and then you can get to all this stuff just like you do in VS Code. So it's kind of the same code base is built on top of. So down here, if you remember from VS Code, you have this wheel down here, and you can select themes. You can go to color theme, and of course, you can just go up and down arrow to find another theme that you might like better. And again, this is, up to the individual person. I'm just going to stick with a darker version like I had. And I'm just going to stick with this Positron dark theme. But that's how you can set up the theme. And you can also say browse additional color themes, and then it goes out on a marketplace, and then it will load there. And then it's a matter of just cycling through these. And when you hit enter, it's going to install it onto your Positron software. All right, so that's a little bit about theming. You can also go to keyboard preferences. So open keyboard shortcuts. So as you can see here you can choose the hotkeys you want to use in order to set this up. And there's also a possibility, for example, if I'm in Quarto, I can just say Quarto. And as you can see here, there's all these run all cells, run cell, and then they give you some hotkeys you can use. So you can set this up yourself, and much like you do in VS Code. All right, I'm not going to spend a super amount of time here because this is stuff you can play around with yourself. Another thing you should be aware of is that this tool is for data science. So this one is just as much home with Python code as it is with R code. And currently you can see I'm pointing to this Python virtual environment. And it will basically load a bunch of stuff. So if I go here now, you can see these are all the virtual environments I can hook up to and just choose, and then I can write code over here in my Quarto document as needed. I also have R, so I can just choose R. And as you can see up here, now it's set for R. So that's the one I'm going to be using. You can see up here, these are the type of customized layout. You can set up just the way you want to lay this whole thing out. I'm currently in a split thing. So I got the code file on the left, and then I got the console on the right, as you can see. So that's my layout currently right now. Okay, and of course you got output and problems, ports, debug consoles, and all kinds of stuff you expect to see in a modern tool such as VS Code, or in this case, Positron, data science tool. So I'm going to get started then, so we can get going here so that this video doesn't become so long that we can never finish it. I don't know about the site here. I'm just going to use Control+, so I get it a little bigger. So notice here in R, you created a cell like this, and there's a shortcut to creating these cells. And if you get stuck, and like I don't have my shortcut working, so for me it's a little tedious, because basically what I have to do is I have to go on my Windows machine here because I don't have the shortcuts working properly. I say right click, I go to Command Palette, and then you can see here I got Quarto, say that, Quarto insert code cell. And it's supposed to be Alt-Q, but it doesn't work for me when I do Alt-Q like this. But when I click on it here, it seems to work. So I was able to fix my cell insert. And let me show you how I did it. Control-Shift-P and open keyboard shortcuts. You see this insert code cell? All I had to do was find one because there was another one that was actually using the combination with the I, Control-Shift-I. So what I did was I went to this Quarto insert code cell, click on this edit button, and then you can say press down the control key, the shift key, and then some combination. So if I set 1 here, you can see control 1 has 2 existing commands. And if you click on it, it will show you what they are. So that is not one I want to use. Insert code cell, and I want to press the Control-Shift-7. If you see there's 2 of them now because I have created both of them. If you basically want to find a combination that doesn't exist here, and therefore that will let you actually create this key. So you can see one. There's also a way you can set up so VS Code, the Positron, act as the same key combination you use in RStudio you can use here, but you have to set it up. And if you check out that video I showed you, I think they might talk about that in that video. So anyways, here I was able to get Control-Shift-7, and that will take care of it. So if I close this now, and if I want to create a new cell, I simply go Control-Shift-7, and now I don't have to insert it. I can just type that key combination. I just want to show you that. So you can mix between markdown and code cells. Now, I don't have much markdown going here. I just type it in like this, because the point here is not to create a Quarto document, it's more showing the R code and getting some data. Okay, so let's get started. So let me delete this particular cell, and I'm just going to highlight it and delete it. Okay, so now I'm going to go to the very top, and then I'm going to load all these libraries. If you're going to use TidyQuant, You need to also maybe use tidyverse because they're kind of connected to one another. And TidyQuant, tidyverse, and I'm going to use DuckDB. Okay, also I'm loading the GT library for tables, and we'll see that in a bit. Now in Windows, I can just, inside a cell like this, I can either click this, run cell, or I can hit Control Enter. So I had Control Enter, and as you can see over here, it's been loading all this stuff over here right now. So the next thing I want to do is, and this is a tedious process because basically I'm going to get the symbols using the TQ index, which is a TidyQuant function you can use to find indexes. You can find out what kind of indexes you can retrieve by using this TQ underscore index underscore options from the TidyQuant library. So as you can see, you got the Dow, you got S&P 400, 500, and 600. You can also run this command, this TQ get the options, and these are the type of information you can retrieve from the different providers, such as Yahoo Finance, such as FRED for economic data. FRED stands for Federal Reserve Economic Data. And you can get from Quantal and this Tingo. So there are a few providers that provides you with data here. So what I'm going to stick with is this S&P 500, which is like 500 stocks of the most prestigious companies in America. So some of the bigger, profitable companies makes it into this index. So there's 500 companies. Now there might be a couple of extra records coming through here, but it's supposed to be in Standard & Poor's 500 index. So what I'm doing here is I'm using this TQ index. Notice I had the TQ index options here, but you can also specify an index inside this TQ index. And then I'm using a pipe operator, and then I'm filtering a symbol out because I notice when I get the results back here, I'm getting one record that has just a dash in it, which shouldn't be there because it ruins the retrieval of data. So if I run this now, notice down here now, I got some data coming through. So in my session here, let me clear this console here. And as you can see, this one is a table data frame. And I can notice this now. I can click here and I can actually see the data that came back here. So there is a company, there's an identifier, and there's some other stuff. And it even tells you the weight that each one of these companies have within the S&P 500 index. So that's quite interesting. You can see this Apple here has a 7% weight in this index. So you can also sort and do all kinds of stuff. So let's say sort descending. And as it turns out here, Apple seems to be the highest by 7%, followed by NVIDIA and Microsoft. So those are the bigger percentage weights in this index. So that's how one thing you can look at. And of course, you can see what currency it's denoted in and how many shares. And of course, these are in scientific notation. So anyways, you got a symbol, we got the name in this. And over here, you're going to see some interesting, remember, this is a data science tool, and it will tell you how much min, max, etc. is. But I'm not going to look at this particular one. I'm going to load some data now. But what I'm going to do is, which is really cool, look how few lines of code this is. I got all the S&P 500 companies in this command. Now I want to get 10 years of daily stock data. Now, some of the companies in here won't have 10 years. For example, Palantir company will not have 10 years because they became public company in around 2020 or so. Somewhere around there. So that's only a few years. But we're going to try to retrieve 10 years worth of data from 2014, 0101, to the latest day of 2024. Now, this will take 4 or 5 minutes to run because it's going to loop over all 500 companies, and it's going to take the ticker, and it's going to look for stock prices from Yahoo Finance, and it's going to retrieve 10 years for each company. So that will take a little while. And I'm running it here through R. Let me run that cell, and I'm going to pause the video. So if we go in and search for TidyQuant, you're going to get here. So in other words, if you go here and you say TidyQuant, and you can say data, TidyQuant financial analysis right here. So you can go in here, and then you end up here. So over here, you can see this is an overview over what it is. So make sure you can check it on YouTube here if you need to. You can actually look at the source code, as you can see up here, browse source code. And they lay it out here, exactly what it is. And there are a few videos that talks about this on YouTube too as well. So make sure that you check this out, and it tells you how to install it. And it also tells you these different areas of how to work with it, like charting, performance analysis, and they have labs, as you can see here. So here's the introduction. There is plenty of information about each part, and it shows you a little bit. It shows you the core TidyQuant functions. So if you go under articles here, you can see these are the type of things you can check out. So if you do a performance, which is what we're looking at, using the performance analytics package that is basically umbrellaed by this TidyQuant, you can scroll down and you can see quick examples here. They give you code, and then you can substitute your own code here, much like you can see the ticker symbols here. Here's the td-get that we're just looking at. So this is kind of what we're doing right now in our download here. So make sure you check out the TidyQuant library to get a better feel for how this works. It even gives you the company, the identifier, all the stuff that you get from the other file, as you can see here, and the local currency. And then it adds the actual stock data. So you can see the date, open, high, low, close, and volume and adjusted close. So that's what we're used to from our regular get stocks. But here they appended this stuff to it. So that's interesting. You only need this one file, basically. You don't need to work with this company file because that's just to use, so we can loop through it and get the actual ticker symbols that belongs in that index. You can also look for some of the other functions. For example, this transmute fun options. Now, if you run that, you can see over here, it gives you a couple of functions here. So if you scroll up, you can see there's a lot of functions you can actually take advantage of, like rolling, like momentum functions, like, there's a bunch of them. So you can look at how you can use these different functions within the library of performance analytic, quant mode, some of these other libraries in there, and use those. But again, you can also go back to the TidyQuant help files and look there as well. So one thing I should point out that might not be covered so far is that in order for you to combine the market data with the regular SP500 data, so in other words, create a benchmark, you need to also query for the S&P 500 index prices. And you can do that by passing in this symbol right here, the GSPC with a little hat in front of it, and do the same thing as far as the time goes. Then what you can do is you can mutate that and rename it to just GSPC. That's what I'm doing here. Now, in order to do that, I set it into that same variable here, so I get it with a new fresh name. And if you look at that, you can see over here now, when I open this column here, you can see I have it as GSPC. And of course, now you can study the statistics or the histograms that comes with the distribution for this. Now, this is just the price data, as you can see here. It does not have any returns or anything, but we're going to base it on the index adjusted and calculate those returns. But I just want to make it clear that you also have to add the market index, okay, to that table object up here. So that's what I'm going to do. So I created this, as you can see, and then what I do is I combined the actual S&P stocks returns that does not have the GSPC ticker. I combine that with the GSPC ticker, as you can see here. By doing that, I'm adding these rows that comes back, which, as you can see over here, is the 2,767 rows of 8 columns. I'm adding that into the stocks, the SP5 stocks of 1,352,331 rows. So that will add it in there. I'm not sure if I already added it in here. So this number here, 1352, already includes these. I just want to point out this method here. Now, here is what I'm going to do next. I'm going to create a function called calc monthly returns, because the data we got from that call we just did of 500 shares is for daily. So there's a lot of data. And what I'm going to do here is I'm going to create this function. And notice it puts it down here so you can see it, just like you do in RStudio. But this is where I'm going to actually create a table, or a tibble, I should say, that represents the 500 stocks monthly data returns. So it's going to basically have a couple of columns only. So as you can see here, I'm going to calculate this monthly return, which is the functions I have up here. I'm going to base it on the adjusted column, which is the adjusted price, if you will, adjusted for stock splits and dividends. And I'm going to mute up using this function. Is going to be monthly, and I want to use the log function. It's the ln function in Excel, if you will, natural logarithm. And I'm passing in everything here, and basically I'm going to run this through, and then I'm going to give it a name here. So let me run this now, and it's probably going to create another tibble object over here. So I'm running, and you can see it up here. It tells you the progress, and it's done. So here you can see after we ran it through from daily to monthly, it went from 1,300,000 to 64,395 rows in 3 columns. Now, if you open this, it might be a little easier to work with. As you can see here, once you open this, you can see the symbol. Well, that was not a good one. Let me look at the dates. So you can see the min date is 1/31/2014, which makes sense because it's the end of the month of the first month we started with 0101, and now it's the end of that month. And it shows you the max, which is the last day of 2024. So that makes sense. Now, return data, you can see here, this doesn't necessarily give you what you want because this is all of them. So that's not good. So let's see one thing we can do. You see this plus sign here? I can select the column. So I can filter it. So if I want to say, for example, I want to find out how much records we get for Palantir because I know we don't have 10 years. So what I can say is take the symbol where it's equal to, and then I'm just going to type it in, PLTR. And then I'm going to apply that filter. So now I'm getting specific data for Palantir. As you can see, there's no missing symbols, which is great. You don't want that. The dates, as you can see, is 2020-09/30 through 2024-12/30. So that's a stock I don't want to compare with all the others that has 10 years worth of data. As you can see, this only has from 2020-09/30. So that's not a good one to use if you're going to plan on having them equal. So here you can see the returns. You got a histogram. And as you can see here, the min is, whoa, look at that min. 38% negative. That's a huge variation here. And the max is, whoa, 98%. So as you can see, this one is fluctuating quite a bit. And the SD, I think, is a standard deviation of 24.5%. So yeah, okay, this one is all over the place, as you can see. You can see the distribution. It's not a normal curve here, as you can see. But there's very few data points to base it on. If you look down here, it's only 52 rows. So that is not a good one to use for analysis. And you can see it's only 0.08% of all the total number of records in this tibble, which is 64,395. So this gives you really good overview over the data science portion or analyzing data inside here. So it's really neat. It's really cool the way they laid it out. Okay, I'm going to stop this video right here, and then we're going to continue in the next video where we're going to actually do a lot of stuff, putting data into DuckDB and take it out of DuckDB and do some more analysis. Thanks for watching this video, and I hope you like it. And if you do, please give me a like and consider subscribing to my channel. That'd be great stuff. And I'll see you in the next video.